The wall clock hangs slightly higher than eye level. Its second hand moves in small, precise steps. Each movement produces a faint sound that blends into the room so completely that it almost disappears. Almost. A monitor on the far wall refreshes. The image does not change. A horizontal line remains stretched across the screen, marked with dates, labels, and colored divisions. Someone updated the display years ago and apparently never found a reason to replace it. The line begins near one edge of the screen and ends near the other. Entire civilizations occupy only small sections of it. The room itself is quiet, not silent. The ventilation system continues moving air through narrow ducts above the ceiling panels. Paper shifts occasionally when someone walks past a shelf. Somewhere behind the archive wall, a machine starts and stops, then starts again. Nothing feels unusual here. Calendars line one cabinet drawer after another. Some are printed on thin paper, others are bound into thick volumes. Decades of schedules, records, appointments, observations, inventories, and reports sit organized in rows. Labels face outward. Dates remain easy to find. Most people trust calendars for the same reason they trust clocks. They work. A meeting begins when the calendar says it begins. A train arrives according to a schedule. A birthday returns at a predictable interval. Seasons change in roughly the expected order. Life becomes easier when time can be divided into pieces and stored. The second hand continues moving. A person seated near the monitor scrolls through a digital timeline. The movement is slow. One finger on a wheel. A small shift downward. More dates appear. Then more. Several thousand years pass across the screen in less than a second. The scrolling stops. Nothing dramatic happens. The timeline simply remains there. Dust drifts through the projector light near the ceiling. Individual particles become visible for a moment and then vanish back into the brightness. A few settle on the edge of a shelf already covered by decades of accumulation. The room contains many ways to measure time. Wall clocks, wristwatches, computer timestamps, printed calendars, archived reports, replacement schedules for equipment no longer installed, maintenance logs, boxes labeled with years. Some of those boxes have not been opened in a very long time. A person could spend an entire afternoon here moving from one date to another without ever leaving the room. The monitor refreshes again. The line remains unchanged. Recorded human history extends back several thousand years. That fact often sounds larger when spoken aloud than when viewed physically. In conversation, several thousand years can feel enormous. On a wall display, arranged into a clean graphic, it becomes something else. Manageable. Surveyable. A distance that can be crossed with a glance. The person at the monitor zooms out slightly. The line becomes thinner. Labels grow closer together. Nothing has changed except scale. The room remains calm. Someone turns a page. Paper brushes against paper. A chair shifts across the floor. The clock continues marking seconds with the same confidence it had a minute ago. No instrument here appears uncertain. That may be part of why archives feel reassuring. An archive is full of completed measurements. Events happened. Dates were assigned. Records were stored. Questions were answered well enough to file away. The atmosphere encourages a particular kind of confidence. If something exists in a labeled box, it feels contained. If it appears on a timeline, it feels understood. At least enough to organize. The monitor emits a soft glow against the wall. The horizontal line remains visible beside the clock. One measures passing seconds. The other measures accumulated years. Both appear equally trustworthy. A maintenance sticker on a nearby cabinet lists inspection dates from previous decades. Someone has initialed each completed entry. The handwriting changes over time. Different people, different pens, the same routine continuing. Inspection completed. Date recorded. Move forward. The procedure repeats. Most systems inside the room operate this way. Measure something, record it, store the result, return later if necessary. Outside the building, weather changes. Day becomes evening, evening becomes night. None of it feels relevant from inside the archive. The room maintains its own rhythm. Monitor refresh. Clock tick. Page turn. Ventilation hum. Monitor refresh. The repetition becomes easy to ignore. And after a while, something else becomes noticeable. Not wrong, not alarming. Just noticeable. The timeline on the wall feels surprisingly small. Not because it contains too little information. The opposite is true. It contains an enormous amount. Entire generations appear there. Entire governments, languages, migrations, discoveries. Yet the eye crosses it effortlessly. The person seated at the monitor scrolls once more. Thousands of years move past. Then stop. The clock beside the display continues counting individual seconds exactly as before. Neither system disagrees with the other. The calendars remain accurate. The records remain organized. The dates remain useful. Everything inside the room continues working perfectly. A second hand advances again. The monitor refreshes. And for a moment, the long horizontal line on the wall seems less like a vast expanse of time and more like an object sitting quietly beneath a clock. A cold light shines downward through the glass case. Beneath it sits a dark piece of sediment, no larger than a closed hand. The surface is uneven. Tiny grains catch the light while other sections remain dull and matte. A small label card stands beside it. The printed text is clean and ordinary. Visitors pass the display every day without stopping for very long. A monitor mounted nearby shows a timeline. The display looks familiar. Horizontal line, date markers, small labels, the same visual language used in archives, classrooms, and museums. A cursor moves slowly across the screen. Someone zooms out. The line shrinks. The sediment does not move. The monitor changes scale again. The line shrinks further. At first, nothing seems unusual about the comparison. Museums do this constantly. A historical artifact appears beside information explaining where it belongs in time. A tool, a fossil, a fragment of pottery, a preserved leaf. Everything receives a place. The process feels natural because chronology feels natural. One event follows another. One century follows another. One civilization replaces another. Human history arrives already organized into sequences. The cursor drags the timeline downward. Another scale appears beneath it. The upper line remains visible. The lower one stretches far beyond the width of the display. A moment later, the software automatically adjusts. The historical line becomes thinner. The geological scale remains unchanged. The sediment continues sitting beneath the glass. A cooling fan starts somewhere inside the monitor housing. The sound remains steady for several seconds before fading back into the room's background noise. Nearby, a visitor leans closer to read a label and then moves on. The display case remains exactly as it was. Earth formed roughly 4.5 billion years ago. The statement appears on a panel several feet away from the sediment sample. Most visitors read the number once. Some read it twice. Very few remain standing there long enough to compare it against anything. Large numbers often behave strangely. They seem understandable until something physical appears beside them. The cursor continues moving. The historical timeline now occupies only a narrow strip across the screen. Dates remain visible. Ancient kingdoms remain visible. Empires remain visible. Recorded history remains completely intact. Nothing has been removed. Nothing has been questioned. Only the scale has changed. The display software performs another adjustment. For a moment, the historical line becomes so thin that the cursor passes over it without appearing to touch anything at all. Then the image sharpens again. The line returns. Still present. Still accurate. A museum employee walks through the gallery carrying a clipboard. Shoes cross polished flooring. A door opens briefly in a distant hallway. Air pressure shifts. The glass case reflects movement for a second and then returns to stillness. The sediment remains where it has always been. Its age is printed on the label. Most visitors probably glance at the number and continue walking. That is understandable. The rock does not look old. Age is difficult to see directly. Weight can be lifted. Distance can be measured. Temperature can be felt. Time rarely leaves such obvious traces. The monitor refreshes. The historical line remains visible. A civilization may occupy centuries, sometimes thousands of years. When compared against neighboring civilizations, those durations feel immense. Entire languages emerge, borders move, buildings rise and collapse. Generations live and disappear. The scale feels large because everything nearby shares roughly the same proportions. The geological display does not share those proportions. The cursor slides outward again. The timeline compresses. Dates crowd together. Labels begin overlapping. The display removes some of them automatically. A software routine designed to preserve readability. The geology remains readable. The history becomes difficult to see. Nothing has happened to history itself. The comparison changed. That seems to be the important part. Not the age of the rock. Not the number on the wall. The comparison. A person standing in front of the monitor folds their arms and watches the display. After several seconds, they zoom back in. The historical line expands immediately. Dates separate. Labels return. The timeline becomes comfortable again. Readable. Human-sized. The screen now resembles the archive display from earlier. The same confidence returns with surprising speed. Years regain their familiar spacing. Centuries regain their familiar weight. Everything feels normal. Then the cursor moves downward once more. The geological scale returns. The compression begins again. This time the process feels less surprising because it has already happened once. Adaptation arrives quickly. The eye starts expecting the historical line to shrink. The mind begins accepting that outcome before it appears. A few moments later, the line becomes nearly invisible again. Not erased. Not challenged. Simply too thin to behave like the main feature on the screen. The sediment under the glass remains motionless. The display stabilizes. The cursor stops moving. For several seconds, nothing changes at all. Visitors continue walking through the gallery. The cooling fan hums quietly. The monitor glows, and across the lower portion of the screen, a timeline containing everything recorded about human civilization rests above a scale so large that the line itself is difficult to see. City lights emerge first. Not continents, not oceans, not borders, just clusters of light suspended against a curved surface. A weather satellite image updates on a monitor. Thin cloud systems stretch across part of the hemisphere. The image advances by a few minutes, then a few more. The clouds have shifted slightly. Nothing dramatic, just enough movement to notice if someone watches long enough. The cities move too. Slowly. Almost imperceptibly. The display sits inside a quiet operations room where several screens show weather patterns, orbital tracks, and incoming satellite data. A mug rests beside a keyboard. Someone has left notes on a desk. A printer hums briefly in another corner of the room before falling silent again. The images continue updating. Most people experience cities from the inside. Streets feel fixed. Buildings remain where they were yesterday. A familiar store occupies the same corner. A traffic light changes above the same intersection. Stability becomes difficult to question because nearly every daily experience reinforces it. From orbit, the experience changes. The city remains visible. The stability becomes harder to see. A sequence of images plays across one of the screens. Several hours compressed into a few seconds. Night covers part of the planet. Thousands of illuminated clusters mark places where people live, work, drive, cook dinner, watch television, or fall asleep. The lights drift steadily across the display. No individual city appears to be moving. The surface carrying all of them is. A technician scrolls through archived imagery. Different dates appear in a corner of the screen, different seasons, different years. Cloud formations vary. Storm systems arrive and disappear. Snow expands across northern regions and later retreats. The motion never completely stops. Earth rotates once every day. The fact is familiar enough to sound ordinary. Many familiar facts behave differently when observed instead of remembered. The monitor advances another frame. A coastline has shifted slightly toward the edge of the image. The city lights move with it. Nothing unusual is occurring. The display is functioning normally. Outside the building, people walk across parking lots and sidewalks without noticing the movement beneath them. Cars stop at intersections. Deliveries arrive. Storefronts open. Evening traffic begins forming in certain districts. The surface feels still because everything nearby shares the same motion. A person standing inside a moving train often feels motionless until they look through the window. The orbital images create something similar. The city remains recognizable. The sensation changes. Cloud bands stretch across thousands of kilometers. Their shapes evolve gradually as the sequence continues. Some dissolve, others expand. A storm system rotates over open water. Sunlight begins reaching the edge of the frame. The boundary between night and day approaches. The lights closest to dawn begin fading, one by one. Then by hundreds, then by entire regions. The cities do not disappear. The darkness moves away from them. The effect repeats every day. The repetition makes it easy to overlook. A weather map updates again. The imaging software overlays timestamps and orbital information. Data arrives from instruments moving far above the atmosphere. Signals travel downward. Computers process them. New images appear. The procedure feels routine because it is routine. Yet, the images continue showing the same condition. A populated surface rotating beneath its inhabitants. The operations room remains quiet. Cooling fans circulate air through equipment racks. Small indicator lights blink steadily. Someone reviews an older satellite pass and compares it against a recent one. The planet looks familiar in both. Movement remains present in both. Sometimes the eye adapts quickly enough that the motion disappears from awareness. The city becomes the object again. The surface becomes background. Attention returns to weather forecasts, shipping routes, population centers, and infrastructure. Then a sequence plays at higher speed. Clouds sweep across oceans. Night crosses continents. The dawn line advances, and the surface becomes visible again. Not as scenery, as motion. Earth also circles the sun. That movement does not appear directly in the satellite feed. The monitors show weather, oceans, cloud structures, and illumination patterns. Daily rotation dominates what the eye can observe. The larger motion remains mostly hidden. Like many large systems, it continues operating without demanding attention. A technician pauses the sequence. The image freezes. For a moment, everything appears stable. Cities remain fixed. Clouds stop drifting. The dawn boundary stops advancing. The illusion returns immediately. Then playback resumes. The clouds continue moving. The boundary advances again. The light slides slowly across the curve of the world. Several screens away, another satellite pass begins loading. Fresh imagery appears line by line. Data becomes picture. Picture becomes weather map. Weather map becomes another ordinary tool used to understand tomorrow. The room remains occupied by routine. The planet remains occupied by motion. Neither condition interferes with the other. The sequence continues playing on the monitor. City lights drift gradually across the night side of Earth. The cloud belts keep shifting. The dawn line keeps advancing. And long after the viewer stops paying attention to it, the lights continue sliding across the darkness. The monitor displays a calibration grid. Thin lines cross the screen from top to bottom and left to right. Small numerical markers sit along the edges. A timeline occupies the lower half of the display. Another scale extends beneath it. The software has already aligned them. No warnings appear. No errors appear. The system considers the comparison valid. A researcher moves the cursor toward the corner of the screen and scrolls outward. The view expands. The historical timeline immediately contracts. Another movement. The line contracts again. The process happens so smoothly that it almost looks natural. The few labels disappear. The software removes them automatically to prevent overlap. Dates that were readable seconds ago become too crowded to display. The system chooses clarity over completeness. Less information remains visible. The zoom continues. The monitor now shows a larger portion of Earth's history. The calibration grid remains unchanged. The software has not altered the data. It has only altered the scale used to display it. The distinction becomes important. A timeline can remain accurate while becoming difficult to see. The room around the monitor is quiet. Cooling systems push air through equipment cabinets. Indicator lights blink in steady intervals. Someone enters a value into a workstation and waits for the display to update. Nothing dramatic is happening. The timeline continues shrinking. A moment later, the researcher stops scrolling. The image stabilizes. Earth's history occupies most of the display. Human history occupies a narrow mark near one edge. The monitor remains perfectly readable. The historical line does not. For several seconds, nobody touches the controls. The calibration grid remains fixed behind everything else. Tiny divisions spread evenly across the screen. They measure distance, not meaning. The software does not know which events feel important to the people viewing them. It only measures scale. Modern humans occupy a very small fraction of Earth's history. The statement itself is familiar. The display creates a different experience. Facts often behave differently when converted into visible proportions. A person can hear a number and continue thinking normally. A person can see that same number translated into physical space and experience it differently. The researcher zooms out once more. The historical line becomes thinner. Not smaller in reality. Smaller on the display. The distinction remains important. Nothing has happened to civilization. Nothing has happened to language. Nothing has happened to memory. The representation has changed. The effect accumulates anyway. A label marking a familiar period remains visible near the edge of the screen. The text appears clear enough to read. Then another scale adjustment occurs. The label shrinks. The letters compress. A moment later, the text becomes difficult to recognize without leaning closer. The timeline remains present. The label remains attached. The information still exists. Visibility has become the problem. A printer activates briefly somewhere behind the workstation area. Paper advances through rollers. The sound lasts only a few seconds before stopping. Nearby, someone lifts a mug from a desk and sets it down again. The room continues operating normally. The monitor continues operating normally. The timeline continues, becoming harder to examine. The software contains a minimum display threshold. When objects become too small, certain labels disappear entirely. Otherwise, the screen would become unreadable. The threshold activates. Several markers vanish. Nothing has been deleted. The software simply stops drawing them. A strange condition emerges. The historical periods remain inside the data. The viewer can no longer see them. The researcher pauses, then zooms inward slightly. Immediately, the labels return. Text becomes readable again. Dates separate. The line regains thickness. The effect feels almost comforting. Scale contracts. History returns. Scale expands. History fades. The transition repeats so consistently that it begins feeling mechanical, almost procedural, like a property of the display itself. The researcher runs the sequence several more times. Inward, outward, inward, outward. Each cycle produces the same result. Eventually, a simple observation becomes difficult to avoid. The problem is not whether history exists. The problem is whether a truthful scale can keep history visible. The monitor does not answer. The calibration grid remains unchanged. The software continues performing exactly as designed. Beyond the building, cities continue moving across Earth's rotating surface. Clouds continue shifting above oceans. Daylight advances across regions that were dark only hours earlier. The planet remains active. The display remains still. The researcher zooms farther outward than before. Earth's history stretches across the screen. Human chronology compresses into something that resembles a fine scratch near the edge. The cursor hovers above it. For a moment, the pointer appears larger than the period it is identifying. Then the researcher increases magnification slightly. The line returns. Not because it grew, because the observer changed scale again. The room settles into silence. Cooling fans continue humming. Indicator lights continue blinking. The monitor glows against the darker surroundings. Near the edge of the display, a date label remains attached to a line so thin that it is almost impossible to read without moving closer. The software still recognizes it. The data still contains it. The line is still there. Barely. Morning light reaches the observatory before anyone else does. The first beam appears along the edge of a hallway floor. Pale gold spreads across polished concrete. A glass door at the far end of the corridor catches the light and reflects it onto a nearby wall. Dust becomes visible inside the illuminated air. The building remains quiet. No voices. No keyboards. No equipment checks. Only the gradual arrival of daylight. A light meter mounted beside a doorway records the change automatically. The numbers increase by small increments. The display updates every few seconds. No one watches it happen. The sensor continues measuring anyway. Sunlight moves farther across the floor. The edge of the illuminated area advances slowly enough that movement is difficult to notice directly. A person returning an hour later would see the difference immediately. Standing still, the change almost disappears. The observatory operates this way throughout most mornings. The star rises. The building responds. No decisions are required. In one room, several monitors remain active through the night. Cooling fans circulate air through equipment cabinets. Status indicators glow softly against darker surroundings. One screen displays environmental readings. Another records incoming measurements from instruments outside. Everything waits. The light continues arriving. A thin layer of dust rests on a windowsill overlooking part of the facility. Individual grains become visible as the sunlight reaches them. For a few minutes, they appear bright. Later, they blend back into the ordinary texture of the room. Nothing about the scene feels unusual. That may be why it is easy to overlook. The sun is approximately 4.6 billion years old. The statement exists in textbooks, databases, and educational displays. It often appears alongside diagrams and measurements. Most people encounter the fact briefly and continue with whatever they were doing before. The hallway receives another section of light. The sensor readings increase again. The building remains occupied by routine. Outside, roads begin filling with traffic. Deliveries arrive, stores open, coffee machines start, computers power on. Schedules begin unfolding according to plans made days or weeks earlier. The morning feels organized by people. The illumination arrives independently. A maintenance worker enters the observatory carrying a small toolkit. The person crosses the hallway, unlocks a storage room, and disappears behind a door. Several minutes later, the door opens again. The sunlight has advanced slightly farther across the floor. The movement never paused. A large amount of human activity depends on stable conditions that rarely receive attention. Agriculture, navigation, seasonal planning, weather systems, electrical demand, daily routines. Generations of observation accumulated before becoming assumptions. Most assumptions eventually become invisible. The arrival of morning is one of them. Inside a control room, a monitor displays overnight sensor logs. The information scrolls across the screen in orderly columns. Temperatures, light levels, instrument status reports, timestamps. Nothing appears remarkable. Most entries look nearly identical to entries recorded yesterday, and the day before, and countless days before that. The repetition creates reliability. Reliability creates familiarity. Familiarity often removes the need to notice something. The sunlight reaches a row of empty chairs near a window. Metal frames reflect brief highlights. Shadows shorten and shift position. A notebook left on a desk receives direct illumination for the first time that morning. The notebook contains observations made by people. The light does not... The distinction feels small, yet it remains present. Human history contains governments, migrations, inventions, conflicts, discoveries, languages, and archives filled with dates. The previous displays showed how difficult that history becomes to see when compared against larger scales. This room offers a different condition. No comparison is required. The light arrives. The instruments respond. The day begins. Everything else happens inside that sequence. A bird lands briefly on a railing outside one of the observatory buildings. The shadow appears on the concrete below. A few seconds later, the bird leaves. The shadow disappears. The sunlight remains. The light meter records another increase. No announcement accompanies the change. No special significance appears on the display. The measurement simply updates. Many systems behave this way. They continue operating whether anyone observes them or not. The observatory gradually becomes occupied. Doors open. Conversations begin. Equipment checks start. Someone reviews overnight data. Another person prepares observations for the coming evening. The building transitions from stillness into activity. The sunlight continues moving across walls and floors at the same pace as before. Nothing about its behavior changes when people arrive. A researcher pauses beside a window and looks outside. Beyond the facility, hills remain visible beneath the growing brightness of morning. Air currents create slight movement in distant vegetation. A weather station updates automatically. Another ordinary day. Another routine beginning. The monitors remain active. The sensors remain active. The star remains active. The relationship feels less like a comparison than a dependency. Not because the sun occupies the center of a diagram, because every record in every archive, every timeline on every screen, every city light crossing Earth's rotating surface, and every date attached to human history occurred beneath the same continuing source of light. The observatory settles into its daytime rhythm. Equipment hums softly. People move through hallways. Data accumulates. And across a section of floor that was dark only hours earlier, the morning light continues advancing, arriving exactly as it did before anyone came to watch it. The monitor refreshes at exactly the same interval as before. A new line appears near the bottom of the display. Numerical values update. The timestamp advances. The graph extends slightly farther to the right. Nothing on the screen suggests urgency. Nothing suggests discovery. The observatory has received another set of solar measurements. A technician reviews the incoming data while drinking coffee that has already cooled. One window displays intensity readings. Another shows instrument status. A third contains archived logs stretching back through previous months and years. The newest measurements resemble the older ones. The software records them anyway. Cooling fans continue running inside equipment cabinets. Air moves through filters. Small indicator lights blink in familiar patterns. Somewhere down the hallway, a printer produces a short report and then falls silent. The monitoring cycle repeats. A measurement arrives. The value is recorded. The graph updates. The archive grows slightly larger. Then the process begins again. Outside, morning progresses across the facility. The sunlight that entered empty hallways earlier now reaches occupied rooms. Shadows shift along walls. Reflections move across windows. People pass through doors carrying notebooks, tablets, and equipment cases. Inside the data systems, another measurement arrives. Then another. Then another. The sun does not appear dramatically different in any of them. That is not considered a problem. Main sequence stars remain stable for extremely long periods. The phrase appears in scientific papers and technical documentation. It is often presented as background information before attention moves elsewhere. Inside the observatory, that background condition occupies most of the workload. Not because the star is changing rapidly. Because it is not. A researcher scrolls through archived records. Weeks pass across the screen, then months. The graph changes slightly from one section to another, but the overall structure remains recognizable. Peaks appear, small fluctuations appear, calibration adjustments appear. The larger pattern remains intact. The monitor refreshes again. The newest point joins thousands of earlier points. The graph barely notices. Many important systems attract attention by changing. Storms develop, signals weaken, machines fail, temperatures rise. Warnings appear. The solar monitoring displays often do something less dramatic. They continue. The distinction becomes easier to observe after spending enough time near the instruments. A maintenance checklist hangs beside a workstation. Several items have been marked complete. Filter inspection, sensor verification, data backup confirmation, clock synchronization. Another employee signs the next entry and moves on. The procedures look routine because they are routine. Most of the observatory exists to support repetition. Measurements continue arriving throughout the afternoon. Software compares incoming values against expected ranges. Automatic systems flag unusual behavior when necessary. Most entries pass through without comment. Accepted. Stored. Archived. The process requires very little interpretation. At one desk, a monitor displays records collected before the current staff began working here. Another archive contains measurements collected before some of those staff members were born. The formatting differs slightly. Older software generated different visual layouts. Some labels appear outdated. The measurements remain usable. The monitoring cycle remained recognizable. A graph produced decades ago resembles one produced this morning. The continuity feels almost mechanical. Dust drifts through a beam of light near a window. The particles move unpredictably. Some rise briefly before falling again. The motion is visible for a few seconds and then forgotten. The instruments continue recording. A person can spend an entire career observing the sun and encounter remarkably little visible change in its overall behavior. Individual events occur. Variations occur. Activity rises and falls. The underlying condition remains stable enough that generations can organize expectations around it. The observatory does exactly that. Data accumulates. Archives expand. Procedures continue. The star remains operational. Late in the day, another review session begins. Several technicians compare current readings against previous records. A few notes are entered into a database. A calibration check confirms expected performance. The results are stored with thousands of earlier checks. Nothing unusual appears. The absence of unusual results becomes its own recurring condition. The monitors glow softly against the darker interior of the room. Cooling systems continue humming. Outside, sunlight gradually begins leaving parts of the facility that were illuminated all afternoon. The measurements continue arriving. The graphs continue extending. The archives continue growing. A curious imbalance develops. Human lives move quickly through the system. Employees arrive, work, retire, and disappear from the records. Equipment is replaced. Software is updated. Buildings are renovated. The same monitoring routine survives those changes with relatively little adjustment. Not because the observatory refuses to change, because the condition being observed changes so slowly. Evening approaches. A researcher closes one data set and opens another. The visual appearance changes. Different graphs, different labels, different scales. The rhythm remains familiar. New value. Stored value. Archived value. Another measurement joins the sequence. The instruments continue recording. And deep inside databases that now contain far more entries than any single person could examine individually. Thousands upon thousands of measurements describe a star that appears almost unchanged from one day to the next. The telescope dome begins opening shortly after sunset. A narrow section of sky appears first, then a larger section. Metal panels continue sliding apart with a low mechanical sound that echoes briefly inside the structure. Cool evening air enters the observatory and replaces the warmth accumulated throughout the day. The movement stops. The opening remains fixed above the telescope. Outside, the first stars have already become visible. Inside the control room, monitors glow against dimmer surroundings. A night shift operator reviews weather conditions, tracking schedules, and instrument status reports. Most values remain within expected ranges. Nothing requires immediate attention. The telescope waits. The sky continues darkening. A tracking motor activates beneath the mount. The sound is subtle, more vibration than noise. Position indicators update on a nearby display. Coordinates change gradually as the instrument aligns itself with a selected target. The process feels familiar. Every night begins with similar routines. Calibration, verification, alignment, observation. The procedures are older than most of the equipment performing them. A star appears on one monitor as a bright point surrounded by darker pixels. The image sharpens after a small correction. The point remains steady near the center of the frame while the tracking system compensates for Earth's rotation. The adjustment happens continuously. Without correction, the star would drift. With correction, the telescope drifts instead. The distinction rarely matters to the software. The image remains centered. Another star enters a different field of view, then another. The screens gradually fill with objects separated by distances difficult to imagine physically but easy to overlook visually. On a monitor, the separations appear small, a few centimeters of screen space. The sky rarely advertises distance directly. It mostly appears as light. A technician compares current observations against archived reference images. File names scroll past. Observation dates appear beside them. Some were recorded recently. Others were recorded years earlier. The stars remain recognizable in all of them. The files differ. The light does not appear to. Outside the dome, more stars emerge as twilight fades. The atmosphere settles. Air currents become less turbulent. Image quality improves slightly. A weather sensor updates automatically. Wind speed, humidity, temperature. Everything continues being measured. The telescope rotates a few degrees toward another target. Motors engage. Stop. Engage again. The movement is careful and deliberate. Once the alignment completes, the instrument becomes motionless. The sky continues moving overhead. The tracking resumes. A person standing outside the observatory might experience the night very differently. Looking upward feels immediate. A star appears present, visible, current. The eye naturally accepts the scene as something happening now. Most visual experiences work that way. The observatory introduces a small complication. Not through mystery, through procedure. Every observation arrives after travel. The amount of travel varies. Some stars are relatively nearby, others are not. The differences become obvious in databases long before they become obvious emotionally. A distance column sits beside a catalog entry. Another number appears beside another star. The values change. The points of light look almost identical. A monitor refreshes. The image remains stable. The tracking motors continue making tiny corrections that are barely audible unless the room becomes completely quiet. A notebook rests beside one workstation. Several pages contain observation logs written during previous shifts, object names, times, conditions, short comments. Most entries are practical. Visibility good. Tracking stable. Conditions acceptable. The sky often encourages simpler language than expected. The longer people observe it, the more procedural the experience becomes. Hours pass this way. Images collected. Files stored. Coordinates checked. Stars tracked. The dome remains open above it all. At some point during the night, attention begins drifting outward, almost without intention. Not because the observations become more dramatic, because repetition creates room for noticing different things. The stars remain points of light. The distances remain hidden behind catalog entries, yet a subtle mismatch develops. The sky feels immediate. The information attached to it does not. A star visible tonight may have begun its journey toward the observatory long before the current equipment existed. Long before the current shift began. Long before some archived observation logs were written. The observation itself remains ordinary. The timing becomes harder to place. No alarm appears. No contradiction appears. The telescope continues functioning exactly as designed. The mount rotates toward another target. Motors hum briefly and stop. A fresh field of stars settles onto the display. The tracking system locks onto its position. The operator reviews the image and moves on. Outside, the sky stretches across the observatory in every direction. Inside, monitors continue receiving arrivals. Light arrives. Software records it. Storage systems archive it. The process repeats. Near the end of the shift, a star field remains displayed on one screen longer than necessary. Nothing unusual about it. No rare object. No exceptional event. Just a collection of ordinary points scattered across a dark background. The tracking motors continue making corrections. The telescope continues following the sky. And on the monitor, light from different distances remains gathered together in the same quiet image, arriving at the observatory at the same moment. The monitor displays a rotating model of the Milky Way. A thin line extends from a bright point marking the sun's position. Several overlay paths curve through the disk. Spiral arms remain visible beneath transparent tracking layers. The animation advances slowly enough that movement is difficult to notice unless the viewer watches continuously. At first, it resembles any other scientific visualization. Colored lines. Reference markers. Motion compressed into something visible. A researcher sits at a workstation reviewing galactic survey data collected across multiple observing programs. Several windows remain open simultaneously. One contains a star catalog. Another contains orbital simulations. A third displays archived measurements recorded by observatories separated by decades. The cooling system hums behind the equipment racks. The model continues turning. The sun occupies a position roughly halfway from the center of the galaxy toward its outer regions. The marker remains fixed on the display while the simulation advances through time. Nearby stars follow their own paths. Spiral structures shift gradually. Distances that appear modest on the screen represent enormous separations in physical space.
The animation remains patient.
Nothing moves quickly. A coffee cup sits beside the keyboard. Someone left handwritten notes near the edge of the desk. A date appears in the corner of one page. Another date appears several pages later. The entries span years of observations. The differences between the dates feel obvious. The movement inside the galactic model does not.
A tracking overlay updates.
The orbital path advances another fraction. The display continues calculating. Human history is full of motion. Calendars advance. Generations replace one another. Languages evolve. Buildings appear and disappear. Records accumulate in archives. The previous rooms in this documentary were filled with timelines, measurements, and dated observations. Those systems created a sense of duration. This model creates something slightly different. The researcher zooms outward. The Milky Way occupies more of the screen. The sun's orbital path becomes easier to see. The line curves around the galactic center in a broad arc that appears almost complete until numerical labels appear beside it.
The labels change the impression immediately.
The path is much larger than it first seemed. The workstation remains quiet except for cooling fans and occasional mouse clicks. A database query finishes running. New entries appear. The simulation continues in a separate window without interruption. No warning messages. No discoveries. Only motion. The sun requires hundreds of millions of years to complete a single orbit around the Milky Way. The statement appears in textbooks and research references. Most readers encounter it briefly and move on. The rotating model behaves differently. The movement remains visible. The duration does not. A timeline appears beneath the simulation. Historical periods occupy a highlighted section near one edge. The highlighted region looks substantial for a moment. Then the researcher expands the scale. The highlighted section shrinks. The expansion stops. The highlighted section remains visible, but only barely. The simulation continues rotating. Nearby workstations display unrelated observations, telescope logs, instrument diagnostics, calibration reports. Someone reviews detector performance from the previous week. Someone else compares survey images collected years apart. The room contains many forms of timekeeping. The galactic model seems reluctant to participate. Its motion unfolds according to a different schedule. A brief realization arrives almost accidentally. The archives feel large. The orbit does not. The researcher replays another simulation run. Spiral arms drift across the display. Star populations redistribute gradually. Orbital tracks overlap and diverge. The sun's path advances again. The difference between the beginning and end of the animation remains surprisingly small. The software is not malfunctioning. The scale is. Or perhaps the observer's expectations are. The distinction remains unclear. Several minutes pass with almost no new information appearing. The model rotates. The database updates. Cooling fans continue pushing air through the room. The galaxy keeps moving. The movement simply refuses to become dramatic. A maintenance notification appears briefly in one corner of the screen. Backup completed successfully. The message disappears a few seconds later. The simulation continues. A notebook beside the workstation contains observation records from multiple years. Different handwriting appears throughout the pages. different researchers, different projects, different priorities.
The notebook feels old.
The orbit does not. The mismatch grows harder to ignore. Not because anything extraordinary happened, because nothing did. Human chronology accumulates visible milestones. The galactic motion does not provide many. No seasonal markers, no annual celebrations, no familiar intervals. The movement continues whether anyone records it or not.
The model turns.
The path advances. The reference frame begins shifting.
A city can change within a lifetime. A nation can change within a few generations.
Scientific institutions can appear, expand, reorganize, and disappear entirely while the galactic orbit remains visibly unfinished.
The simulation demonstrates this without emphasizing it. The display simply keeps running. An operator leaves the workstation briefly and returns several minutes later.
The model appears almost identical to how it looked before. Position labels have changed slightly. Numerical values have advanced.
Visually, very little seems different. Procedurally, everything remains active.
The orbit continues. The researcher minimizes several windows and leaves the galactic model alone on the screen. Without surrounding information, the image becomes strangely simple.
A rotating galaxy.
One marked orbit.
One moving reference point.
The room settles into late-night quiet. Equipment remains active. Data continues flowing through systems that never completely stop. The observatory persists in its routines.
The model persists in its own.
And on the monitor, the sun continues following a path so long that entire civilizations appear less like separate chapters within it and more like observations made during the same unfinished turn.
The image on the workstation sharpens line by line. At first, the screen appears filled with static textures,
Pale regions, dark regions, uneven bands stretching across the display. Small processing indicators move along the bottom edge while software assembles incoming survey data into something more coherent.
The room remains quiet.
Cooling fans continue humming. A hard drive activates briefly and then stops.
The image continues resolving.
A spiral arm gradually emerges from the noise.
Not all at once.
One section becomes recognizable first, then another. Dust lanes appear as darker interruptions crossing brighter regions. Dense concentrations of stars create irregular patches of light. Gas clouds occupy larger areas than the eye initially expects. The software finishes another processing step.
The arm becomes clearer.
A researcher leans slightly closer to the monitor. No urgency, no discovery alert. This is ordinary survey work. Data arrives, processing routines run, images improve. The procedure repeats across observatories and research institutions every year.
The spiral arm remains on the screen.
Most people encounter the Milky Way as a band across the night sky, a familiar feature, something visible from dark locations far from city lights. The experience feels immediate because it is visual.
This display feels different.
The image resembles a structure rather than a view.
The distinction is subtle. The processing software overlays reference markers.
Catalog identifiers appear beside several regions, distances, survey designations, observation records. Most of the labels remain too small to read from across the room. The arm itself remains easy to see.
A large concentration of stars extends diagonally through the display. Dust occupies the spaces between them. Some regions appear dense and crowded. Others seem comparatively empty. Nothing about the structure suggests a preferred location. Nothing identifies where a civilization might exist. The image processing completes. The indicators disappear. The arm remains. Outside the observatory, the night continues normally. Wind moves through vegetation surrounding the facility. A vehicle crosses a distant road. Clouds develop over a horizon that nobody inside currently needs to monitor. The survey image remains open. A star-forming region occupies one section of the display. Another region contains older stellar populations. Gas flows through larger structures. Material gathers, disperses, rearranges. Most of the motion remains too slow to witness directly. The image captures a condition rather than an event. A notebook rests beside the workstation. Observation schedules fill several pages. Object names, times, assigned instruments, future sessions waiting to occur. The notebook feels organized around human planning. The spiral arm does not. The researcher opens another survey image collected using different wavelengths. Some structures become brighter, others fade. Dust that blocked visible light appears differently now. Hidden regions emerge. The overall shape remains recognizable. The arm persists through the change. A simple fact becomes difficult to avoid after enough exposure to these images. Spiral arms contain enormous concentrations of stars, gas, and dust. The sentence sounds straightforward. The display stretches it into something physical. The arm occupies the monitor. The monitor occupies a desk. The desk occupies a room. The proportions feel manageable even when the underlying structure is not. Several minutes pass. Nothing dramatic happens. The image remains visible. The researcher compares one survey against another. Small differences emerge between datasets. Resolution improves. Boundaries sharpen. Additional details appear. The arm continues existing beneath every adjustment. A maintenance cart rolls through a hallway outside the control room. Wheels briefly rattle against a floor seam. The sound fades. Someone closes a door in another part of the building. The survey image remains unchanged. This section of the galaxy existed before the workstation, before the observatory, before the survey program currently displaying it. The thought arrives quietly and then drifts away again. The image itself remains more interesting than the implication. Dust lanes curve through the structure. Dense regions interrupt wider fields of stars. Some areas appear crowded beyond easy counting. Others create the impression of open space until magnification reveals countless additional objects. The eye keeps adjusting. The structure keeps extending. The Milky Way is often described as home. The phrase appears in documentaries, books, and educational material. Sitting in front of a survey image creates a slightly different feeling. Home usually implies familiarity. The arm on the screen feels familiar only in fragments. A star here. A gas cloud there. A recognizable pattern surrounded by larger patterns. The workstation clock advances another minute. The image remains open. The researcher leaves briefly and returns carrying a fresh cup of coffee. The survey remains exactly where it was left. Processing finished. Data stored. display unchanged. The arm did not require observation to continue existing. It simply remained. The room settles into a quieter rhythm as the night progresses. Equipment stays active. Storage systems continue archiving observations. Cooling fans maintain the same steady sound that has followed the documentary through several different rooms and several different scales. The survey image remains visible on the monitor. Dust lanes cross brighter regions. Star fields extend beyond the edge of the display. And somewhere within a structure too large to perceive directly, one spiral arm continues turning through the galaxy whether anyone is watching it or not. The database window expands across 3 monitors. Rows appear faster than anyone can read them. Object identifiers, coordinates, observation timestamps, survey flags, processing status markers. New entries arrive while older entries continue sliding downward beyond the visible portion of the screen. The room is lit mostly by displays. Server fans produce a constant layer of sound beneath everything else. A storage array activates briefly. Several status lights blink. The catalog grows. No individual entry appears important. That is partly the point. A researcher reviews a section of the database and opens a record at random. A small image appears beside a collection of metadata. Observation date, instrument source, position information, processing history. The image shows a distant object. The metadata occupies more space than the image itself. The record closes. Another record opens. Then another. The procedure continues. Modern sky surveys spend much of their time creating organization rather than discovery. Images arrive. Automated systems identify sources. Software compares observations against previous records. Objects receive identifiers. Duplicates are removed. Measurements are attached. The process rarely looks dramatic. Most of it resembles administration. A cooling fan changes speed inside one of the server cabinets. The sound rises slightly before settling again. Nearby, a workstation displays incoming observations waiting to enter the main catalog. A progress indicator advances. The queue shortens, then fills again. The catalog continues expanding. Human memory tends to organize information differently. A person remembers a place, a conversation, a photograph, a night sky viewed from a familiar location. Memory gathers around events and experiences. The database does not. Coordinates remain beside coordinates. Identifiers remain beside identifiers. Every object occupies roughly the same amount of space on the screen. The distinction feels small at first. The workstation refreshes. Several new entries appear. One object receives an updated classification. Another receives a revised measurement. A third remains unchanged. No narration accompanies the process. The software performs its tasks silently. A researcher scrolls through archived observations collected years apart. The object identifiers remain stable even when the observations change. New images replace older ones. Additional measurements accumulate. The catalog preserves continuity through labels rather than stories. A maintenance checklist hangs beside a rack of storage hardware. Several tasks have already been completed during the current shift. Drive verification, backup confirmation, network status review. Someone signs a line near the bottom of the page. The checklist joins many others stored elsewhere in the building. The servers continue operating. A simple observation begins appearing repeatedly throughout the room. Whenever a new observation arrives, it enters a system that already existed before it. The catalog does not pause to make space. It simply grows. A monitor near the far wall displays a sky map covered with small markers. The markers represent recorded objects. Zooming inward reveals more. Zooming outward reveals even more. The map remains readable because software continuously decides what to show and what to hide. Without those decisions, the display would become unusable. The researcher adjusts the scale. The markers rearrange themselves. The underlying catalog remains unchanged. Several minutes pass inside routine activity. Data ingestion continues. Automated scans complete. Processing jobs finish and begin again. Nothing unexpected interrupts the workflow. The room feels less like a place where discoveries happen and more like a place where discoveries are stored. The distinction matters. A discovery is an event. A catalog is a condition. The server room behind the workstation remains closed to visitors. Cold air circulates through narrow aisles between equipment racks. Indicator lights blink continuously. Storage systems receive information from telescopes that may be located hundreds or thousands of kilometers away. The observations travel. The records stay. A technician reviews an older dataset and notices a familiar object identifier. The same identifier appears in newer observations as well. The object has accumulated additional measurements over time. The identifier remains unchanged. The observations multiply around it. A person can remember a handful of details about a familiar star, a familiar constellation, a favorite image collected by a telescope. The catalog does not operate within those limits. The system expects accumulation. Every observation becomes another entry. Every entry becomes another reference. Every reference becomes part of a larger structure. The growth feels procedural rather than dramatic. That may be why it becomes easy to overlook. A printer produces several pages containing processing summaries. The sheets emerge one after another and settle into a tray. Someone collects them and places them beside a stack of earlier reports. Paper records. Digital records. Archived records. The same activity expressed through different storage systems. The catalog continues growing beneath all of them. Hours later, many of the observations collected during the beginning of the shift have already disappeared from immediate attention. They remain accessible, searchable, indexed. But they are no longer being actively viewed. New observations occupy the screens now. New records. New identifiers. New processing queues. The older entries remain inside the system. A researcher pauses on a single record for a moment longer than necessary. Not because the object is extraordinary, because the identifier itself appears strangely detached from ordinary memory. A sequence of letters. A sequence of numbers. A position in a database. The observation feels real. The label feels administrative. Yet the label is what allows the observation to remain findable years later. The record closes. The catalog remains open. The room settles back into repetition. Server fans continue moving air. Storage systems continue receiving data. Automated observations continue entering queues that never remain empty for long. Across multiple monitors, object identifiers keep arriving faster than anyone could remember individually.
And somewhere among thousands of records added during a single shift, human dates remain attached to catalog entries that will eventually be found through database searches rather than remembered through stories. The map fills most of the screen. Small markers float across a coordinate grid. Labels appear beside several of them. Some names are familiar: Andromeda, Triangulum, a scattering of smaller galaxies distributed around them. The software draws thin reference lines between major structures and then leaves the rest of the display mostly empty. Across the top of the window, a title remains visible: Local Group. The map stays open while other programs continue running in the background. Database updates arrive. Storage systems archive observations. Server fans maintain the same steady sound that has followed the documentary through survey rooms, catalog systems, and processing stations. The label remains unchanged. Local Group. A researcher zooms outward slightly. The markers become easier to see. Additional reference information appears around the edges of the display. Distances accompany several objects. Observation data remains accessible through expandable menus. The software presents everything calmly. Nothing about the interface suggests that the word local requires special attention. Most people use the word without difficulty. A local road, a local business, a local weather report. The term usually implies proximity, something nearby, something reachable, something existing within an intuitive frame of reference. The map continues displaying galaxies. The label remains: Local Group. A mouse pointer pauses over one marker. Information appears beside it: position, classification, distance, survey references. The entry looks similar to thousands of other records stored throughout the catalog system. The difference emerges from context, not from presentation. A printer activates somewhere outside the room. Pages emerge. Someone collects them. A door opens and closes in a nearby hallway. The sounds briefly interrupt the steady rhythm of equipment before fading again. The map remains visible. Several galaxies occupy the display. The spaces between them remain largely empty. The software uses scale bars rather than visual texture to communicate separation. Without those indicators, the distances become difficult to judge. The local group spans millions of light years. The sentence appears in educational material so often that it begins to feel ordinary. The map behaves differently. The word local arrives first. The distance arrives second. The researcher zooms inward. Several satellite galaxies appear around a larger system. Labels reorganize automatically. Marker sizes adjust. The software tries to preserve readability. The label at the top remains exactly the same. No warning appears beside it. No clarification. No asterisk. Just Local Group. A coffee cup sits beside the keyboard. Someone left handwritten notes next to a monitor displaying archived survey records. Observation identifiers continue entering databases elsewhere in the building. Administrative systems continue functioning normally. The language remains unchanged. That may be what makes the conditions slightly difficult to notice. The software never treats the label as unusual. The observer does. A second map window opens beside the first. This one displays a familiar section of Earth's surface: roads, cities, geographic boundaries. The scale indicator occupies a small corner. The comparison lasts only a few moments before the researcher closes the window again. No conclusion follows. The local group map remains.
A galaxy marker appears no larger than a point of light on the display. Clicking it reveals another collection of information: observation history, position records, survey references. The database handles the object exactly as it handles everything else. Identifiers, coordinates, storage locations. The administrative systems appear completely comfortable with the arrangement. Several minutes pass. Nothing changes. The map remains open. The label remains visible. A small contradiction begins settling into the background rather than standing out. At first, the word local seems inaccurate. After enough time near the display, it begins feeling normal. The adaptation happens quietly. The observer adjusts. The label does not. A cooling fan accelerates briefly inside a server cabinet and then returns to its previous speed. A status indicator changes color for several seconds before reverting. Automated processes continue moving observations through storage systems. The room remains occupied by organization. The map remains occupied by classification. A familiar word continues, describing a structure that extends far beyond the conditions where the word normally operates. The researcher stops interacting with the display altogether. The pointer remains motionless. The map sits unchanged on the monitor. Galaxies remain distributed across the coordinate grid. Reference markers remain attached. Distances remain available. The title remains visible at the top of the screen: Local Group. And after enough time spent looking at it, the most unusual part of the display is not the galaxies, or the distances, or the map itself. It is the fact that the label never changes, even as the observer gradually stops knowing what the word local is supposed to mean. The visualization begins as a collection of points. Thousands of them. Perhaps millions. The workstation displays a dark background covered with tiny markers representing galaxies collected from survey data. At first, the image resembles many others already seen throughout the documentary. Positions, coordinates, catalog entries translated into something visible. A researcher waits while the reconstruction software processes another layer. Progress indicators move slowly across the bottom of the screen. Server fans continue humming. A coffee cup sits beside the keyboard. The image remains mostly unchanged. Then faint connections begin appearing. Not bright lines. Not dramatic structures. Just subtle traces emerging between concentrations of galaxies. The software gradually reveals them as additional data loads into memory. One cluster appears linked to another, then several more. The display becomes slightly harder to interpret. The galaxies remain visible. Something else remains visible too. A storage system activates somewhere behind the workstation. Indicator lights blink. Another processing task completes. The room continues operating according to familiar routines. The reconstruction continues. Several survey programs contributed information to the model. Different telescopes, different observation periods, different databases. The software combines them into a single representation. The result occupies an entire monitor. The galaxies no longer appear isolated. A researcher zooms outward. The image expands. Individual galaxies become harder to distinguish. Clusters remain visible. Larger shapes begin emerging from the distribution. Dense regions connect through thinner regions. Wide, empty spaces appear between them. The software labels none of this automatically. It simply displays the arrangement.
Several minutes pass with almost no interaction.
The reconstruction remains on the screen. A maintenance notification appears briefly in one corner of the display and disappears again. Backup completed. Storage verified. The same administrative processes continue operating beneath observations that extend across vast distances. The visual pattern remains. At first, it looks accidental. Then, it begins looking structured. The distinction develops gradually. Not because the image changes, because the observer spends more time with it. A galaxy feels large when viewed alone. Survey images taught that lesson repeatedly. Maps of the local group preserved it. Catalog entries reinforced it. Entire observation systems treated galaxies as meaningful destinations. The reconstruction software treats them differently. Here they behave more like locations within something larger. The researcher zooms outward again. Clusters contract into brighter knots. Filaments become easier to see. Empty regions widen. Several familiar galaxies disappear into larger patterns that no longer require individual identification. The names remain stored in databases. The image no longer needs them. A cooling fan changes speed somewhere inside the server rack. The sound rises briefly and then settles. The room remains occupied by machinery and routine. The reconstruction remains occupied by structure. Large-scale structure forms filaments, clusters, and voids. The sentence appears in textbooks. The workstation displays something less verbal. Clusters gather. Filaments extend. Empty regions separate them. The pattern repeats across the screen. A researcher opens another version of the model using different visualization settings. Several colors change. Marker brightness changes. Density thresholds change. The arrangement does not. The same filaments remain. The same concentrations remain. The same empty spaces remain. The software is not creating the structure. It is revealing it. The distinction becomes difficult to ignore. A few moments later, the reconstruction rotates slightly. Not enough to feel cinematic. Just enough to expose depth. Several structures previously appearing adjacent begin separating. Others overlap from a new angle. Distances become harder to estimate. The image starts behaving less like a map and more like architecture. The observer notices this before fully understanding it. The realization arrives awkwardly, almost late. For most of the documentary, galaxies occupied the role of framework. Observations happened inside them. Catalogs organized them. Maps connected them. Language treated them as destinations. The reconstruction assigns them a different role. They become components. The room falls quiet except for equipment. No one reacts. The software continues rendering. A cluster remains suspended inside the model. Thousands of galaxies occupy it. Survey records, object identifiers, observation histories, entire databases worth of information. From this distance, the cluster resembles a bright node attached to a larger structure. Nothing about the rendering suggests that the cluster should be considered an endpoint. A researcher zooms farther outward. The change is subtle. Then suddenly it is not. The galaxies stop behaving like primary objects. The structure connecting them becomes easier to see than the galaxies themselves. The orientation shift happens in a few seconds. The software does nothing special. No label appears. No explanation appears. The observer simply notices that attention has migrated away from individual galaxies toward the arrangement containing them. The reconstruction continues rotating. Filaments stretch across the display. Clusters gather where those filaments intersect. Large, empty regions remain between them. The voids occupy more area than the structures. The structures remain easier to notice. A printer activates somewhere down the hallway. Pages emerge. Someone collects them. A door closes softly. The ordinary sounds of the building continue without interruption. The model remains on the screen. Galaxies continue occupying their positions. Yet something about their status has changed. Not physically. Perceptually. A galaxy still appears enormous. The reconstruction never disputes that. It simply places the galaxy inside a larger context where enormity no longer determines importance. The researcher stops rotating the model. The image becomes still. Filaments remain suspended across the display. Clusters remain attached to them. The empty regions remain open between them. The software finishes its calculations and settles into silence. Nothing else appears. Nothing needs to... The monitor continues displaying galaxies arranged along structures that seem older than the idea of galaxies as destinations, like particles gathered along scaffolding that remains visible even after the observer stops looking for it. And long after the pointer becomes motionless, the filaments remain. The survey image finishes loading. Nothing obvious appears. A faint concentration of galaxies occupies one side of the display. Another concentration occupies the opposite side. Between them stretches a broad region containing very little at all. The software identifies every recorded object it can find. Small markers appear. A few labels become visible. Then the image stops changing. The researcher waits for additional data. No additional data arrives. The exposure is complete. A cooling fan continues moving air through the workstation. Somewhere behind the wall, storage systems archive observations collected earlier in the night. The same low mechanical sounds remain present. The same indicator lights continue blinking. The survey image remains mostly empty. At first, the empty region feels temporary. A person looking at astronomical data often assumes that missing information will eventually be replaced by better information, a deeper exposure, a more sensitive instrument, another observing run. The researcher zooms inward slightly. The empty region remains. Several galaxies become easier to identify near its edges. Distances appear beside catalog entries. Observation histories remain available. The software contains information for everything it can detect. Most of the display still contains very little. The image remains open for several minutes. Nothing emerges from the center. A telescope exposure can spend hours collecting light. The resulting image may contain thousands of identifiable objects. Processing software removes noise. Calibration routines correct distortions. Survey databases compare new observations against older records. The procedures continue. The empty region remains. A mug sits beside the keyboard. The coffee inside has cooled completely. Someone left a folded checklist near the monitor earlier in the evening. Equipment inspections have already been completed.
Data transfers have already been verified.
The room feels occupied. The image does not.
Cosmic voids occupy large fractions of the observable universe.
The statement appears straightforward when written in a textbook.
The survey image behaves differently. The eye continues searching. The expected object never arrives. A researcher opens another survey collected through a different observing program. The color scheme changes. Marker density changes. Detection thresholds change. The same region remains sparsely populated. Several galaxies appear near the boundary. Very few appear inside it. The software recognizes the difference immediately. A machine does not need time to become uncomfortable with emptiness. It simply records positions. The observer requires longer. A small orientation marker sits in one corner of the display. Coordinates update as the researcher moves across the image. Every location remains measurable. Every location remains part of the survey. The empty region is not outside the map. It belongs to the map. That detail becomes easier to notice after enough time passes. The void has boundaries. The void has shape. The void occupies space in the same way a cluster occupies space. A storage array activates briefly. A new observation enters the archive system. Status indicators update and return to normal. The ordinary machinery of the observatory continues functioning without interruption. The survey image remains quiet. Several minutes pass with almost no visible change. The researcher zooms outward. The image expands. Clusters become smaller. Filaments become thinner. The underdense region becomes easier to see. Not because it contains more information, because it contains less. A strange inversion develops. The empty area becomes one of the most recognizable features on the display. The galaxies define its outline. The absence occupies its interior. The software never labels it dramatically. No warning symbols appear. No highlighted borders surround it. The image simply leaves space where space exists. Outside the observatory, wind moves across nearby hills. A vehicle passes along a distant road. Night continues unfolding according to familiar rhythms. Clouds form and dissipate beyond the horizon. Inside the survey image, almost nothing changes. The stillness feels different from the stillness of a stored photograph. The region remains active. Expansion continues. Gravity continues operating. Light continues crossing it. The eye simply receives very little evidence of those activities. A researcher leaves the workstation briefly and returns several minutes later. The image appears almost identical to how it looked before. Coordinates remain visible. Galaxy markers remain attached to the same locations. The empty region remains empty. The familiarity arrives surprisingly quickly. After enough observation, the absence stops feeling unusual. The observer adapts. Attention begins drifting toward the boundaries instead. Small concentrations of galaxies, faint filaments, catalog entries along the edges. The center receives less attention because there is less to notice there. Then, occasionally, the attention returns. The region remains. The condition becomes difficult to describe using ordinary expectations. Emptiness usually suggests a missing object, a missing signal, a missing measurement.
This region is not missing. The surveys found it repeatedly. The coordinates remain stable. Independent observations agree. The absence itself has become part of the observation. A printer activates somewhere down the hallway. Paper emerges. Someone collects the pages. A door opens and closes. The sounds fade back into the background hum of equipment. The workstation remains unchanged. The survey remains unchanged. Near the edges of the display, galaxies continue outlining a shape that contains remarkably little. The boundaries remain visible. The interior remains sparse. And long after the observer stops searching for what should be there, the void continues occupying its place inside the map as a condition rather than a gap. The map assembles itself one layer at a time. A cluster appears first, then another. Thin structures emerge between them. Additional survey data loads from archived observations collected across different years, different instruments, and different observing programs. The workstation continues combining them into a single image. A progress bar advances slowly across the bottom of the screen. The cooling fans maintain the same steady sound. The map grows larger. A researcher waits without touching the controls. There's little to do while the software processes the remaining observations. Storage systems continue transferring data in the background. Status indicators blink. A maintenance log remains open on a secondary monitor. The map continues expanding. At first it resembles the earlier reconstruction, clusters connected by larger structures, voids separating them, familiar patterns appearing at greater scale. Then another layer arrives. The image extends beyond the previous boundaries. The software automatically rescales the display. The orientation changes slightly. Several structures that appeared large a few minutes earlier become smaller components inside something broader. Nothing dramatic happens. The software simply keeps adding observations. Superclusters extend across enormous cosmic distances. The statement appears frequently in reference material. Survey archives store it alongside measurements, coordinates, and classifications. Inside the workstation, the fact behaves differently. The map keeps changing size. The observer keeps adjusting. A cluster that once occupied much of the display now appears as a small concentration near one edge. Labels remain attached. Catalog entries remain available. Observation histories remain preserved. The information survives the rescaling. Its importance feels less stable. A printer activates somewhere behind the control room. Paper slides into a collection tray. Someone retrieves the pages and leaves. The sounds last only a few moments before disappearing into the background hum of equipment. The map remains open. Another layer appears. The software redraws everything. Maps usually improve orientation. Roads become visible. Boundaries become visible. Distances become understandable. A person expects to know where they are after spending enough time with a map. The supercluster reconstruction behaves differently. Each expansion reduces familiarity. The observer recognizes more information and understands less of the whole. The distinction arrives gradually. A researcher zooms inward briefly. Individual galaxy clusters return. Familiar structures become recognizable again. Observation markers appear. Catalog identifiers re-emerge. For a moment, the image feels manageable. Then the scale returns to its previous setting. The familiarity disappears almost immediately. The room remains occupied by ordinary activity. A coffee cup rests beside a keyboard. Survey archives continue receiving observations. Backup systems continue running scheduled routines. Equipment remains concerned with procedure rather than interpretation. The map continues growing. A small orientation marker sits in one corner of the display. Coordinates remain accurate. Scale indicators remain accurate. Distance measurements remain accurate. The observer remains uncertain. The software is not. Several minutes pass. The image stabilizes. No new layers arrive. The final reconstruction remains visible across multiple monitors. Bright concentrations gather along larger structures. Void regions separate them. Boundaries emerge and dissolve depending on viewing angle. The arrangement feels less like geography and more like administration. Everything occupies its assigned location. Everything remains cataloged. Everything remains measurable. A strange compression begins appearing only after the map stops changing. Not inside the reconstruction. Inside the observer. The survey archive contains observations spanning decades. Databases preserve records collected before some current researchers began their careers. Older observations remain searchable. Newer observations continue arriving. The archive feels extensive. The map does not seem to notice. A civilization can preserve thousands of years of history. Libraries can accumulate records. Institutions can survive generations. Entire historical periods can occupy shelves, databases, and museums. The reconstruction accommodates them without difficulty. Not because it contains them, because it does not require them. The realization arrives quietly, almost accidentally. History feels large when compared against other history. The map is not organized around historical scale. The workstation refreshes. Nothing changes. The reconstruction remains exactly where it was. A technician reviews several archived survey files and closes them again. Another observation enters storage. A backup verification completes successfully. The machinery continues operating with the same procedural rhythm that has followed the documentary through observatories, archives, databases, and survey systems. The map remains. Several superclusters occupy the display. Distances remain attached to them. Coordinates remain attached to them. The reconstruction stays perfectly readable. Orientation does not. A researcher leaves the workstation for a few minutes and returns. The image appears unchanged. The structures remain mapped. The archives remain active. The scale indicators remain visible. And across multiple screens filled with observations collected over many years, civilization begins feeling less like a framework for understanding the map and more like a timestamp attached to one very small part of it. Cooling fans move air through the equipment racks with the same sound they made an hour ago. A monitor glows softly near the end of the control room. Several windows remain open. Calibration logs, instrument status reports, environmental readings. Nothing on the displays demands immediate attention. Most values sit comfortably inside expected ranges. A technician scrolls through a checklist. One item receives a confirmation mark. Then another. The room remains quiet. The supercluster reconstruction is still open on a secondary monitor, but nobody is studying it now. The image remains exactly where it was left.
Clusters and voids continue occupying the screen without changing shape. The workstation does not care whether someone is looking at it.
The maintenance checklist receives more attention. A detector temperature is verified. A clock synchronization routine completes. A data archive confirms successful transfer. The systems continue operating. Large observatories depend on continuous calibration and maintenance. Telescopes collect observations, but much of the surrounding work involves preventing small problems from becoming larger ones. Dust accumulates. Sensors drift slightly. Clocks require synchronization. Cooling systems require inspection. The routines repeat. Most nights feel similar. A technician plugs in a set of headphones and listens to a short recording collected during an equipment test. The signal plays for a few seconds. Static remains low. No unexpected noise appears. The recording ends. The file is archived. Another task completes. Outside the building, the night continues normally. Wind moves across nearby terrain. Clouds form and dissolve beyond the horizon. The observatory does not respond to every change. Some conditions matter, others do not. The instruments continue measuring. A status light blinks green near a storage cabinet. Several seconds later, it blinks again. The interval remains consistent. Nearby, a backup system updates a timestamp and returns to waiting. Nothing appears dramatic. The room feels occupied by maintenance rather than discovery. That distinction becomes reassuring after spending enough time around the equipment. Not every shift produces something new. Most shifts preserve the ability to recognize something new later. A researcher reviews archived calibration records from previous years. Different names appear beside completed tasks, different dates, different hardware revisions. The procedures remain recognizable. One instrument was replaced. Another was upgraded. A third still operates with components older than some of the people currently working in the building. The records remain organized. The maintenance continues. A coffee machine activates briefly in a nearby break room. Water flows. The sound lasts less than a minute before stopping. Someone walks through the hallway carrying a mug and disappears into another section of the facility. The monitors continue glowing. The logs continue updating. The cooling fans continue moving air through systems designed to remain stable for long periods of time. A calibration routine finishes running. The software reports successful completion. No celebration follows. The result is expected. For several minutes, almost nothing changes. The technician reviews another checklist. The timestamp advances. A storage array receives new observations collected earlier in the evening. Automatic systems sort the incoming files. Everything enters the archive. Everything receives a location. Everything becomes retrievable later. The rhythm feels familiar. Even people who have never worked inside an observatory recognize versions of it. Maintenance, verification, record keeping. Small tasks performed correctly so larger systems continue functioning. The scale of what is being measured does not alter the routine itself. A temperature sensor still requires verification. A clock still requires synchronization. A data file still requires storage. The realities attached to those measurements remain whatever they were before the task began. A technician pauses beside the monitor displaying the supercluster map. The image remains visible. Distances remain attached to structures spread across the screen.
Coordinates remain available. The map has not become smaller.
The technician checks a calibration report instead. A few moments later, the report closes. The map remains. Perhaps that is part of the arrangement. The maintenance routines do not reduce the scale of what is being observed. They do not make the structures easier to imagine. They do not compress the distances into something comfortable. They only ensure the measurements remain trustworthy. The room settles into another stretch of quiet activity. A status light blinks. A log updates. A recording enters storage. A checklist receives another confirmation mark. The observatory continues operating through procedures simple enough to fit inside a notebook. The realities being measured remain outside the notebook entirely. Near the end of the shift, the calibration dashboard refreshes one final time. Every monitored system reports normal operation. The technician saves the report and closes the window. The monitor remains illuminated. The cooling fans continue their steady movement through the racks. And across the room, instruments designed to observe realities larger than any maintenance log continue waiting for the next measurement to arrive. The comparison chart redraws itself after a scale adjustment. For a moment, the display appears normal. Several colored bands remain visible. Labels sit along the bottom edge. Historical periods occupy a section near the center of the screen. Distance markers remain attached to larger structures above them. Then the software finishes recalculating. The chart changes. Not dramatically. A few labels disappear. Several colored bands become thinner. The display remains readable. Mostly. A researcher moves the cursor across the screen and zooms outward again. The adjustment is small, barely noticeable. The result is not. Another set of labels vanishes. The software removes them automatically. There is no longer enough room to draw the text without overlap. The chart remains accurate. The chart becomes harder to use. A cooling fan changes speed inside the workstation. Air continues moving through the equipment racks. The maintenance logs from earlier remain open on a secondary monitor. The status light blinks steadily near a storage cabinet. The room feels exactly as it did before. The chart does not. Comparison charts appear everywhere. Financial reports, weather records, population trends, engineering diagrams. They exist because placing two things beside each other often creates understanding. The procedure feels familiar. One measurement beside another. One interval beside another. One scale beside another. The display continues expanding. The software attempts to preserve visibility. Text becomes smaller. Markers become thinner. Colors become simpler. The chart sacrifices detail in order to preserve structure. For a while, the strategy works. Then it stops working. A historical timeline remains visible along the bottom of the display. The observer can still identify it. Major divisions remain present. Broad periods remain recognizable. The researcher zooms outward again. The timeline compresses. The chart refreshes. A few moments pass. The observer studies the result. The timeline remains present. The individual divisions no longer do. Nothing has been removed from the data. Only from visibility. A printer activates briefly down the hallway. Paper slides into a tray. Someone retrieves it and returns to another room.
The sounds fade quickly.
The chart remains on the screen.
The software continues, preserving accuracy.
A strange process develops.
The comparison itself begins creating the problem. When the scales remain separate, both sides remain visible. When the scales become truthful, one side disappears.
The realization arrives through procedure rather than interpretation.
The software is not malfunctioning.
The chart is... A researcher opens a different visualization tool.
The display changes format. New colors appear. New scaling methods become available. Several options allow compression of large intervals. Others allow selective magnification.
The observer tries them.
The labels return. The chart becomes readable again. Then the researcher disables the adjustments. The labels disappear once more.
The readability had been artificial. The chart had required assistance.
A storage array receives another observation from the archive system. Timestamps update. Backup routines continue running. The ordinary machinery of the observatory remains occupied by familiar tasks.
The comparison chart remains occupied by an unfamiliar limitation. For several minutes, almost nothing changes.
The observer studies the display.
The software remains still.
The room remains still.
A chart is supposed to reveal relationships.
This one increasingly conceals them. Not because information is missing, because too much information survives. The researcher zooms farther outward than before. The display redraws. A broad structure remains visible across the top half of the chart. Large intervals continue occupying physical space on the screen. Their labels remain readable.
The historical section remains attached near the bottom. The observer can still locate it.
Barely. The labels are gone.
The subdivisions are gone.
The distinctions that once felt important no longer occupy enough pixels to survive.
The chart remains technically correct.
A technician enters the room carrying a fresh checklist. Calibration records require review before the shift ends. Several routine verifications remain unfinished. The work proceeds normally. Nobody discusses the chart. Nobody needs to.
The display remains visible beside the maintenance records.
One represents procedure. The other represents scale. The procedures remain understandable. The scale increasingly does not. The observer attempts another adjustment. Different orientation, different layout, different proportions. The result remains similar. The chart can preserve accuracy. The chart can preserve visibility. Eventually, it cannot preserve both. The room settles into another period of quiet operation. Cooling fans continue moving air. Storage systems continue receiving files. Status lights continue blinking at predictable intervals. The chart remains open. A moment of unusual clarity appears almost by accident. The problem is no longer that one scale feels larger than another. The problem is that comparison itself depends on both sides remaining visible. The display no longer guarantees that condition. Several minutes later, the researcher stops adjusting the settings entirely. The chart remains frozen on the screen. One side continues showing structure. The other survives mostly as a thin region attached to the edge of the display. The software still recognizes every interval. The database still contains every record.
The chart no longer helps very much. And as the maintenance logs continue updating beside it, the observer gradually stops comparing the two sides altogether and begins looking only at what remains visible. The monitor displays a reconstruction assembled from survey archives. No labels are visible. The researcher disabled them earlier. Only structure remains. Clusters appear as dense concentrations of light. Filaments extend between them. Broad regions of lower density separate one section from another. The image occupies most of the screen. Nothing identifies a preferred location. Nothing marks a familiar interval. The reconstruction rotates slowly. A cooling fan continues humming inside the workstation. Dust drifts through the light above the desk. The room remains occupied by ordinary things. The image does not. A researcher opens an archived survey frame beside the reconstruction. The older image contains fewer observations. Several structures appear incomplete. Empty regions occupy larger portions of the display. The newer reconstruction contains more information. The overall shape remains recognizable. The researcher studies both images for a few moments and then closes the older file. The reconstruction continues, turning. No comparison replaces it. For a while, nothing needs to. The storage systems continue receiving observations collected during previous nights. New files enter the archive. Existing files remain searchable. A timestamp advances in the corner of a monitor. The structure on the screen does not visibly respond. Large-scale cosmic structures evolve. The motion exists. The reconstruction simply does not display enough of it to become obvious. A cluster remains a cluster. A filament remains a filament. The arrangement persists. A technician walks through the control room carrying a stack of printed reports. The papers shift slightly with each step. A door opens, then closes. The sound disappears. The reconstruction remains. Several minutes pass. The observer notices an unusual absence. Not inside the image. Inside the viewing process. There is no timeline attached to the screen. No historical marker. No compressed reference band. No comparison chart struggling to remain readable. The reconstruction no longer asks what happened during a particular interval. It only displays a condition. The researcher zooms inward. Individual galaxies become easier to identify. Small concentrations emerge from larger ones. Survey markers remain hidden. Object names remain hidden. The image becomes more detailed without becoming more personal. A cluster occupies the center of the screen. Several galaxies drift through the visualization according to calculated motion. The movement is almost invisible. The software includes it anyway. A coffee cup sits untouched beside the keyboard. The liquid inside no longer produces steam. Nearby, a backup routine finishes and begins another verification cycle. Small status lights continue blinking. The observatory remains occupied by repetition. The reconstruction remains occupied by continuity. A few moments later, the researcher zooms outward again. The individual galaxies lose importance immediately. The cluster returns. Then the filament. Then the wider structure surrounding both. The transitions happen smoothly. Nothing feels dramatic. The image simply changes scale. Outside the building,
Wind moves across the surrounding hills. Clouds drift across portions of the sky. A weather station updates automatically and stores the result. The room never reacts. The reconstruction never reacts. Both continue. A survey image opens briefly on another monitor. A familiar section of sky appears. Thousands of recorded objects remain attached to positions collected through years of observation. The image looks static. Then it closes again. The reconstruction remains. The continuity survives the switch. A researcher leans back slightly from the workstation. The structure remains visible from farther away. That detail becomes difficult to ignore. Many observations require magnification. Many measurements require interpretation. The larger structure remains recognizable even after details disappear. The room grows quieter. Not silent. Cooling fans continue moving air through equipment racks. Storage arrays continue receiving files. Automated systems continue processing information without attracting attention. The reconstruction continues rotating. The motion remains slow enough that a person leaving the room and returning several minutes later might struggle to notice any change at all. Yet the software continues calculating. The structure continues evolving. The display simply refuses to hurry. A brief moment of clarity arrives through observation rather than realization. Nothing in the image appears to require a witness. The software requires one. The archive requires one. The workstation requires one. The structure does not. The thought remains for only a moment before drifting away again. The reconstruction keeps turning. A cluster passes across the center of the screen. Filaments extend beyond the visible boundary. Parts of the structure disappear off one edge while other sections enter from another. The image never presents a beginning. It never presents an ending. Only a section currently visible. A technician returns to review the calibration reports left unfinished earlier. Pages turn, notes are checked. Another verification receives a confirmation mark. The routine continues. The reconstruction continues. Neither interrupts the other. Several minutes later, the researcher minimizes every remaining window except the reconstruction itself. The screen becomes simpler. No charts. No timelines. No labels. Only structure. The workstation light reflects faintly from the surface of the desk. Dust remains suspended in the air above it. The cooling system continues its steady circulation through the room. And on the monitor, a filament remains connected to a distant cluster while the rest of the structure extends beyond the visible edges of the display, continuing in directions the screen no longer shows. The second hand advances across the clock face. A small sound follows. Then another. The archive room looks exactly as it did before. The same shelves remain against the walls. The same drawers remain labeled with dates. The same monitor continues glowing near the far side of the room. Dust crosses a beam of light descending from a fixture near the ceiling. Nothing appears different. A researcher enters carrying a folder of printed records and places it beside a workstation. The papers settle. A few corners curl slightly where the stack has been handled many times before. The clock advances again. The room remains occupied by ordinary things. A monitor refreshes. The timeline returns. It stretches across the screen just as it did at the beginning. A thin, illuminated line. Small labels attached to larger divisions. Sections organized into a sequence that remains easy to follow. The display is readable. Comfortably readable. No software warnings appear. No compression routines activate. No labels disappear. The timeline occupies exactly the amount of space required. A cooling system continues circulating air through equipment cabinets elsewhere in the building. The sound reaches the archive room only faintly. Most of the machinery remains hidden behind walls and doors. The room feels stable. The drawer slides open. Inside are records organized by year. Reports, maintenance logs, observation summaries, printed copies of measurements that now exist in digital archives as well. Some pages show signs of age, others were printed recently. The documents remain real. The dates remain real. Nothing about the larger structures seen earlier has changed. That a researcher removes one folder, examines it briefly, then returns it to its place. The drawer closes. The room settles again. Several minutes pass without anything requiring attention. The monitor remains illuminated. The clock continues advancing. Dust continues drifting through the light. The timeline remains visible. Earlier, the comparison charts stopped helping. Labels disappeared. Scales refused to coexist on the same display. Visibility became the limitation rather than information. That condition does not exist here. The timeline is not attempting to contain everything. It only contains itself. A maintenance sticker attached to an older cabinet lists inspection dates spanning decades. Different handwriting appears beside different entries. Some ink has faded slightly. Some remains dark and clear. The cabinet continues standing where it always has. The records remain attached to it. A person can still read them. Outside the archive room, another door opens and closes. Footsteps pass briefly through the hallway. A printer activates somewhere farther away and then falls silent. The ordinary sounds continue. The room never tries to become larger than it is. That detail becomes easier to notice now. The timeline occupies a small section of a much larger reality. The cabinet occupies a small section of the room. The room occupies a small section of the building. The building occupies a small section of a landscape that does not appear on any of the displays. None of those observations reduce the reality of the cabinet, or the room, or the timeline. The monitor brightness shifts slightly as the display updates. The line remains visible. A researcher sits down beside the workstation and reviews several archived records. Dates pass across the screen. Observation reports, equipment notes, maintenance summaries, small pieces of accumulated activity. The review continues for several minutes. Nothing unusual appears. The records remain useful because they describe things that actually happened. The usefulness does not depend on occupying the largest scale. A coffee cup rests near the keyboard. The surface of the liquid remains still. Nearby, a stack of folders waits to be returned to storage. One page protrudes slightly from the edge of a binder. The room feels familiar. Not because it explains reality, because it belongs to reality. The clock advances again. The same sound follows. For a moment, attention drifts toward the monitor. The timeline remains illuminated. Compared to the structures seen earlier, it occupies very little space. The difference is obvious now. The display no longer hides it. Yet the line remains perfectly visible. The line remains accurate. The line remains worth keeping. A researcher finishes reviewing the final folder and places it back on the shelf. The position it occupies is small. The label attached to it is small. The recorded interval inside it is small. The folder remains part of the archive. The archive remains part of the building. Neither requires becoming larger. The room grows quieter as the shift approaches its end. Several monitors elsewhere in the facility continue processing information. Storage systems continue receiving observations. Cooling fans continue moving air through equipment racks. The larger structures continue as well. Nothing has stopped. Nothing has narrowed. Nothing has moved closer. The archive room simply remains where it always was. A final monitor refresh passes across the display. The timeline remains visible. The labels remain attached. The clock continues advancing second by second. Dust continues crossing the light. And on the screen, a small illuminated line remains suspended within a much larger reality, still readable, still accurate, while the clock beside it keeps working exactly as before.